Welcome back to software engineering class. And the next part after component testing is the integration testing. If all the components have been unit tested properly, okay, why do we need integration testing? Integration testing requires us to work across multiple teams, okay? So why do we need to do it? None other because of the fact that when we work across component, okay, the data from one can be lost across an interface to another. So we need to verify this. Second one, because one component, it can have an inadvertent adverse effect on another. So this is another thing that we need to check. Okay, going from one to another. Third, the sub-functions from each component, when they are combined together, may not produce the desired major function that we have designed or that we have written properly in the requirement process. Number 4, individually acceptation imprecision might not be detected at component level, but when we test across several components, it may be magnified to an unacceptable levels, and then we need to do something with it. 5, the global data structures also can present a problem. So it is important to check not only the local structure but as well as the global data, etc. So there are many reasons why we need to do the integration testing. In any case, this is a must. Integration testing is actually a systematic technique for constructing the software architecture, while at the same time we conduct tests to uncover error associating with the interfaces. Okay, and there is often a tendency to attempt the non-incremental integration. That is the Big Bang approach. In this approach, all the components are combined in advance and the entire program is tested as a whole. And normally in this case, chaos usually results. Okay, errors may be encountered, but correction is very difficult to do. And then we need to think of the isolation of causes, complicated by all the vast expense of the entire program and so on. So taking the Big Bang approach is actually a lazy strategy, okay, and we know that it is doomed to be a failure. So the more popular approach is actually the incremental testing, or sometimes also called the scaffolding. So what happened in incremental testing? First, we know that component testing, they may be done in isolation with the rest of the system, and it depends upon the context of the development cycle, okay. So what happened in integration testing? For example, either in the bottom-up or top-down approach, okay, we have, let's say, two components A and B, okay, A and B, and we want to test component A, but B is not ready. So in that case, we use a stub. So here is actually a stub, stub, not sub. All right. So to test A, we use a stub, okay. And then vice versa, if we want to test B, but A is not ready, then we use what we call the driver. So in this incremental testing, we test all the modules or all the interfacing one by one. We choose either a bottom-up or a top-down. So in between, if there are any components which are not ready yet, then we will replace them with the stubs or drivers. All right. In this incremental testing scenario, there's also a concept which is called the regression testing. So what is it? It is the re-execution of some subset of the tests that actually have already been conducted, but we reuse them to ensure that changes that have not yet been propagated, its unintended effect, are also tested. This should be executed every time a major change is made to the software. It can also be executed for minor change, but this will drain our resources, okay. And if we understand the concept of regression, then we can see that if the number of the tests grows bigger, okay, the regression goes higher. We cannot test everything, so we need to include only tests that matter the most. And in recent development, we have seen the proposition of artificial intelligence as well as machine learning algorithm, which are used in the process of identifying these components or subset tests that are useful in the regression testing, most useful in the regression testing. However, we argue that human interaction is still important, and the review from them still needs to be included in this integration testing. There's also the concept of continuous integration. This is a practice where we merge components into evolving software. Okay, so this is done quite regularly. Okay, sometimes up to once every day, or there are companies which want to do it more than once each day. Okay, so the thing is, this happen quite fast. Okay, every small improvement and so on are tested every day. And the one subsection of the continuous integration is called the smoke testing. So this approach, it can be used when the product is developed normally by the agile team. So the smoke testing, the continuous integration approach, and so on, this is very much valued by the agile team. Okay, it can be characterized as a rolling or continuous integration strategy. Software is rebuilt, built and rebuilt every day. Okay, what happens is software components that have been translated into code are integrated into a build. So build, it includes all the data files, libraries, reusable modules, and engineered components that are required to implement one or more product functions. A series of tests is designed to expose errors that will keep the build from properly performing its functions. The intent is to uncover showstopper errors that have the highest likelihood of throwing the software project behind schedule. Okay, so the build is integrated with other builds, and the entire project, okay, or the entire product in the current form is smoke tested daily. So this integration approach may be top down or bottom up. It can be either one, but here it is more on the frequency of testing, and in the, how do we say that, in the complexity of the matters. Okay, so we do it little by little increments every day. That's why we call it a continuous integration. Smoke testing is arguably too much for some people, but we cannot debate on the benefits that it applies. Okay, when we are working with complex and time-critical software projects. The first one is the minimization of the integration risk. Because smoke tests are conducted daily, so the incompatibilities or other showstopper errors, they are uncovered quite early. So thereby it reduces the likelihood of serious schedule impact when the errors are uncovered. Okay. The second one is that the improvement of the quality of the product. Because the approach is construction oriented, smoke testing is likely to uncover functional errors as well as the architectural and component level design errors. So if these errors are corrected early, better product quality obviously will result. Third, error diagnosis and correction are simplified. The thing is, because errors are uncovered quite frequently, so any error that we uncover are likely to be associated with the new software increments. Okay, so because we do it little by little, we know that if we uncover something, this must be associated with the latest development that we have introduced inside the software. Okay, and the progress is easier to assess with each passing day. More of the software that has been integrated and more has been demonstrated to work. So this improves the team morale. Okay, when development every day, even the fact that we uncover error, it can improve the team morale. And it gives the manager a good indication of how much the progress has been made and so on. Finally, when doing this integration testing, what we want to have is actually the testing pattern. So testing pattern are described in much the same way as how we describe the design patterns. The interest is to find patterns that can help others in overcoming their difficulties. So, for example, there are several testing patterns that have been published. Okay, one of them is the scenario testing. Okay, this is the abstract provided by Khan01. There are others which are pair testing and separate test interface, and these are specifically for the object-oriented design. And we can have so many more testing patterns. They are not the focus of our class today, but know that they exist, and it is in the interest of the software tester software engineers, the testers, and find this pattern and try to develop it, and then we might share it either as open source or something that is sellable. And that's it. See you in the web app testing part.